Welcome. In this video, we'll be analyzing horizontal compressions and expansions. Let's go ahead and take a look at our first example. Describe the transformation necessary to obtain the graph of g of x, the dashed line from the graph of f of x, the solid line. So if we take a look at our graph, here we have what we refer to as the original function. So this is the original one. And we are getting the new function, which is in green, okay? This green parabola. Notice that in this case, it seems that in order to get from the blue to the green one, we can pull to the sides, okay? So it seems that we're pulling to the sides, so this is what we refer to as an expansion in the horizontal direction. So we can describe this one as, let's expand horizontally, and to complete that one, we need to describe the factor. So let's write the following: by the factor of, and let me leave that blank for a moment. In order to determine the factor, I like to take a point, usually the one that has an x-coordinate of 1, so I can identify what's going on. Notice this point is 1 unit away from my y-axis. Then, for the same y value, I'm going to choose a point on the new one. That point in this case happens to have an x-coordinate of 3. Okay, so that means that we're expanding horizontally by a factor of 3. Let's see one more example. Example 2. Describe the transformation necessary to obtain the graph of g of x dashed line from the graph of f of x, the solid line. Again, in this case, we know the blue parabola is the original. The green parabola, it's your new one. And it seems that in this case, we're pushing towards the y-axis, okay? So we can picture pushing the blue parabola towards the middle here. So we can say that in this case, we happen to have a compression. So we can say that to go from the blue to the green one, we would need to do the following. We will need to compress horizontally. Okay, notice, because it seems that we're going to be pushing towards the middle, so that we are compressing horizontally. And just as we said before, to complete this whole description, we say by a factor of, and let me leave that blank for now. In this case, again, let me take this particular point, which is 1 unit away on the original one. And if you notice, this point on the green one, it's about a third away, okay? Now, compression, it's already implying the reciprocal of that, because it's already kind of squishing things in. So we can just say the reciprocal 1/3 is 3. That's our factor, okay, of 3. Let's analyze the next one. Example 3, describe the transformation necessary to obtain the graph of g of x from the graph of f of x. We're given that f of x is equal to x squared, and g of x is equal to 1/3 x quantity squared. Now notice that here we need to identify what c is. C is equal to 1/3, okay? And 1/3 happens to be bounded by 0 and by 1. In addition, since the action is taking place inside the grouping symbol, inside the parentheses in this case, we have what we refer to as a horizontal stretch. Okay, this is a horizontal stretch. But in terms of compression and expansions, we can say that here, all we need to do is expand horizontally by a factor of 3. Okay. Why is that? Well, that's pretty simple because every single one of our x coordinates will be multiplied by 3. Okay. Let's go to the next and last example. Example 4. Describe the transformation necessary to obtain the graph of g of x from the graph of f of x. In this case, again, f of x is x squared. G of x is defined as 3x quantity squared. In this case, let's go ahead and identify our constant here. So we have c is equal to 3. Notice that this is greater than 1. Since the action is taking place inside of the parentheses, this is what we refer to as a horizontal shrink. But in terms of compressions and expansions, we can describe this transformation as a compression. So we can say something along the following lines. Compress horizontally by a factor of 3. Okay, so that concludes our examples when it comes to horizontal compressions and expansions. I hope you have enjoyed the video. Have a wonderful day and see you next time.